Hello and welcome to math, where today we're going to do some more stuff with exponents. And we're going to be working with this thing called power of a power, and that's when you have an exponent and it's raised to another exponent. Okay? So let's see, how do we do this? All right, so 7 squared. 7 squared means 7 times 7, right? But 7 squared raised to the 4th power means that 7 squared is happening 4 times. 1, 2, 3, 4, right? So how many sevens do I have? I have 8 sevens. 1, 2, 3, 4, 5, 6, 7, 8, right? So let's say I had another one. So this 2 to the 3rd power raised to the 5th power. That means that 2 to the 3rd power is happening 5 times. 2 to the 3rd times 2 to the 3rd times 2 to the 3rd, 3 times 2 to the 3rd, 4 times 2 to the 3rd. 5. That 2 to the 3rd is happening 5 times, right? That's basically what we did here, right? 7 times 7 is happening 4 times. 2 to the 3rd is happening 5 times. All right, so now I can break this down even more, right? This 2 to the 3rd means that there's 2 2s. Or sorry, 3 2s. This 2 to the 3rd means that there's 3 2s, right? 1, 2, 3. This 2 to the 3rd means there's 3 2s. 1, 2, 3. This 2 to the 3rd means there's 3 2s. 1, 2, 3. This 2 to the 3rd means that there's 3 2s. 1, 2, 3. Man, it's a lot of 2s. All right, so how many 2s do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I got 2 to the 15th power. 2 to the 15th power. So when you see a power raised to a power, so you have an exponent raised to another exponent, that exponent's just telling you how many times that they want you to do that, right? So 2 to the 3rd, they want you to do it 5 times. So 2 to the 3rd times itself 5 times, right? So that means we have a lot of 2's, okay? Let's do an exponent one over here, or a variable one. So I have x squared raised to the 3rd power, right? So x squared raised to the 3rd power means that x squared is happening 3 times. So I'm going to have x squared times x squared times x squared. It's happening 3 times because that exponent here tells me, right? So x squared, that means x times x. This x squared means x times x. This x squared means x times x. All right, so how many x's do I have? I have 1, 2, 3, 4, 5, 6. So this would be x to the 6th power. X to the 6th power. Okay? All right, using what you just discovered, without expanding, can you answer the following? So without expanding, can I answer the following? All right, well, let's see here. It says 2 to the 5th raised to the 2nd power. Let's type it in the Desmos here. Let's do 2 to the 5th power. What is that? 32. All right, so 2 to the 5th power is 32. And that 32 is getting raised to the 2nd power. So that 32 that we just got from 2 to the 5th is getting raised to the 2nd power, because it says here, right? So that gives me 1,024. 1,024. 1,024. Okay? And if you don't believe me, I typed it in Desmos the original way too. 2 to the 5th power raised to the 2nd power gives me 1,024. Same answer, right? Okay, what about 2 to the 10th power? What does that give me? Let's type that in. 2 to the 10th power gives me the same answer, 1,024. Huh. Well, that's interesting. All right. So let's see this one. 3 to the 1st power is just 3. 3 to the 3rd power is 27. Because it'd be 3 times 3 times 3, 27. What is 3 to the 3rd power? 3 to the 3rd power is 27. Okay, that's interesting. Let's try this one. 4 squared is 16. 16 to the 6th power. Let's try that one. I don't know. I can't do that in my head. That's a big number. 16 to the 6th power gives me a huge number. 167777216. So I did 16 to the 6th power, and I got this big long decimal. Not decimal, sorry, big long number. I got 167777216. What is that? 16,777,216. Okay, so what's 4 to the 12th power? Well, it's that same number. It's that same number. Okay, so what is happening here? Can we come up with a rule without, so we don't have to expand it each time? Because some of these can get pretty long, like this up here, right? So what's happening here? So if I can see that 2 to the 5th raised to the 2nd power is the same as 2 to the 10th, what is happening to this 5 and this 2? How do I go from 5 and 2 to get to 10? Well, I can multiply this, right? 5 times 2 gives me 10. 1 times 3 gives me 3. 2 times 6 gives me 12, right? So if I do 4 times 2, that gives me 8, right? So a power raised to a power, we can multiply the two exponents and we'll get the same answer. And that makes it a lot easier, right? Because trying to expand this up here, it'd be kind of a pain, it'd be a lot. You have to write a lot of 4s, right? But I can do 5 times 3. 5 times 3 would give me 15. So that'd be 4 to the 15th. And I'm done, right? So when you have a power raised to another power, you can multiply those exponents. All right, so let's do some of the variables then, right? So if I have x to the 8th power that's raised to the 5th power, that would be x to the, I do 8 times 5. 8 times 5 is 40, so that'd be x to the 40th power. So now that I know that rule, it makes it a lot easier, and I don't have to write 40 x's, right? All right, so 4 to the 2nd power raised to the 3rd power. Well, that would be 4, and then 2 times 3. 4 times 3, or 2 times 3 is 6, so that'd be 4 to the 6th power. Y to the 8th and then raised to the 3rd. 8 times 3 is 24, so that'd be y to the 24th power. All right? 6 times 2 to the 3rd, so that would be 6 times, and then we have 2 times 3, and 6, that'd be 6, and 2 times 3 is 6, that'd be 6 to the 6th power. Okay? So, is this a true statement? When you have mn, is it the same as nm? Go ahead and explain that. See what you do. All right, what we don't want to forget is we don't want to forget about the rules we already have in place, like negative exponents. So, like this example here, I have x to the 5th raised to the negative 2. So that means this whole thing here, this whole x to the 5th is getting raised to the negative 2. So this has to get moved to the denominator. So up top, I'm only going to have a 1 left. Down here, I'm going to have my x to the 5th raised to the 2nd power. Positive, right? So the top would still be 1, but now my bottom, 5 times 2 gives me 10. So it'd be 1 over x to the 10th. All right, and that kind of makes sense, right? Because if I did x to the 5th times negative 2, because we're multiplying these exponents, right? A positive times a negative would give me a negative, so that would be x to the negative 10th. Well, what's x to the negative 10th? Because we can't have negative exponents. It's this exact same thing right here, right? So I can multiply it. So 3 times 3, and that's to the negative 2 power, times to the negative 4th power. Well, 3, all right, 3 is my base. That's going to stay. Negative 2 times negative 4, 2 negatives make a positive, and 2 times 4 is 8. So it'd be 3 to the 8th power. Okay? Let's do this one, all right? Negative 2 times 8 will give me negative 16. So that would be 1 over x to the negative 16. But I can't have a negative, so I got to bring it up to the numerator. So it would be x to the 16th. Okay? So we don't want to forget about negatives. Negatives are kind of hard, but we have to know them. We have to know them. All right? What about if I had numbers in front, like these? Numbers in front, I just multiply like normal, right? So 4 times 8 is 32. 32, the 8 is negative, so it'd be negative 32. Negative 32. All right? And then now I can do the exponent, and that's the 5th power raised to the 7th power. So I can multiply those two. And 5 times 7 gives me 35. So it'd be x to the 35th power. Okay? So we can't forget about our rules that we already had. But when you have a power raised to a power, we have to multiply those two. We can multiply. We don't have to. You can expand it out. But with some of these, they'll be super long. Like x to the 5th times raised to the 7th, you're going to be writing out a ton of numbers. Oh, I forgot about one here. All right, because I also have this x to the 3rd, x to the 2. So that would be x to the 3rd times x to the 2nd. So that would be x to the 6th. Ooh, x to the 6th, good catch. So x to the 6th times x to the 35th. Right? Okay, so then I could expand all this out. Or when you expand it out, that means I have 6 x's and I have 35 x's. So how many x's do I have? I have 41 x's. Okay? All right, so we can't forget about the rules we had, right? We have to keep those rules in place, right? And then when you have a power raised to a power, you just multiply the two exponents. All right, so think back to when we did distributed property. Distributed property, we took the number on the outside and we multiplied it to the stuff on the inside, right? So negative 3 times x would be negative 3x. Negative 3 times 4 would be negative 12, right? That negative 3 is getting multiplied to everything on the inside. right? You can try these ones on your own later. Do these ones on your own, right? So with distribute property, we had to distribute whatever was on the outside to everything that was on the inside, right? And with exponents, when you have a power to a power, you can have the exact same thing. So if you ever have an exponent like this one, it's on the outside of parentheses, it's got to go to everything on the inside. Just like how we did distribute property, right? The number on the outside went to everything on the inside. Same thing for these. This 2 has to go to that -3 and to the x, right? So it's going to two things. So the 2 goes to the -3, which is right here, and then it's also going to the x. And -3 squared is 9, x squared is 2x squared, right? So let's do some of those. All right, so I have a 3 on the outside here. This 3 has got to go to everything on the inside. It's got to go to everything on the inside. So that 3 is now going to be raised to the third power. So it's going to be 3 to the third. All right, and now we learned earlier that x to the fourth, that already has an exponent, right? So it's an exponent with another exponent, so I can multiply those and get my final exponent. So 3 to the third as a number, so I can solve that. That's 27. X is still there, and now I have 4 times 3 from exponent. 4 times 3 is 12. All right, so let's do another one. All right, so I have a 5 on the outside here, right? So this 5 is going to go to everything on the inside. Everything on the inside. All right, so B didn't have an exponent, so it's really a 1. 1 times 5 is 5. And then C has a 3, so I can do 3 times 5, and 3 times 5 is 15. Okay, this one I would have 2, that 4 is going to go to both things. It's got to go to the 2, and it's got to go to the x to the third. So that means that's going to be 2 to the fourth, and it's going to be, that x has a 3, so it'd be 3 times 4. Well, 2 to the fourth I can do, because that's just a number. That's 2 times 2, which is 4. 4 times 2, which is 8. 8 times 2, which is 16. So that would be 16. And then my x's, I multiply my exponents, and 3 times 4 is 12. Okay? Try these two on your own, all right? But when you have a power raised to a power, the key takeaway is you multiply the two exponents. And that'll save you a lot of time from expanding out, because some of these exponents will get pretty big, especially when you have like 7 raised to the 9th, right? Or something like that. That means you'd have to write out 63 x's. Nobody wants to do that, right? So when you have a power raised to a power, we multiply our exponents, and that's how we can simplify it. All right, if you ever have any questions, please ask a teacher. Try the rest of these on your own. I'll see you next time. Bye!